Welcome back to All This Math. This is Professor Parker. We're doing some Eureka math, grade 6, module 4, lesson 9. We back to lesson 9. We already did videos for example 1, example 2, and example 3 in this particular lesson, lesson 9. Now we're on to it. We're on to example number 4, and we're going to talk about it. So the first question posed is, how can we show 10 minus 6? How can we show 10 minus 6? I know some people might look at that and say, well, what you mean? How can we show 10 minus 6? 10 minus 6 is 4. We just know that. We just write 4. That's how we show it. Well, 10 minus 6 is 4. That is correct. But we're trying to practice with drawing diagrams so we can visualize and create pictures of the math that we're doing, right? Because that's something that we want to become familiar with. We want to become comfortable with that, right? Visual representations of the mathematical practices that we're partaking in, right? Visual representations, right? Because when we get to higher level math, right, we're going to have more advanced and complex equations, and these equations can be modeled in the form of graphs, straight lines, curves, different types of curves, V-shaped graphs, parabolas, all types of stuff. So we want you to get prepared for that by doing this here now, right? Because everything you do in math is you're not just doing, it's not busy work. Don't think it's busy work. You're doing it because it's going to prepare you for the higher level. It's going to prepare you for the next level. It's like when you was a baby, you learn how to crawl. Crawling helps you to learn how to walk. Walking helps you to learn how to run and all that. All right. So it's the same kind of concept. All right. So how can we show 10 minus 6? We've been doing bar diagrams and throughout lesson 9. We're going to do a bar diagram right here. So watch this. Matter of fact, let me consult my, okay. I had to look at my notes real quick. So 10 minus 6. So if we start, that means we start out with 10 and we take away 6. Subtraction means take away. We're taking away 6. We start out with 10, we take away 6. So what I'm going to do is I'm going to draw 10 boxes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my bar diagram, right? I got 10 boxes. That's the 10 that I start out with, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you draw your bar diagram, do your best to make sure that each of the individual boxes are the same size, same dimensions. Just do your best. You don't got to be perfect, but just try to do your best to make them as close to each other in size as possible. All right, so we start out with 10, and then we're going to take away 6. So what I need to do is I need to represent the 6 that I'm going to take away. I'm not taking away 4, I'm not taking away 5, I'm taking away 6. So since I'm taking away 6, what I'm going to do is I'm going to shade in 6, but I'm going to shade in 6 from the end. From the end. I guess it don't really matter, but I'm going to shade in 6 from the end. So I'm going to shade in 1, I'm going to shade in 2, I'm going to shade in 3, I'm going to shade in 4, I'm going to shade in 5, I'm going to shade in 6, right? So now I got 10. Now let me do this. The whole thing was 10. That's the entire bar, right? Entire bar, right? So the entire bar was 10. I'm taking away 6. So this is being taken away. And that's how, and we already knew the answer was 4 because we know our subtraction facts, right? 10 minus 6 is 4. But this is a visual representation of what's happening. Because if you start out with 10 and then you take 6 away, what am I left with? 1, 2, 3, 4. So that's a visual representation. All right. You start out with 10, you take away 6. This also could be seen as 6 less than 10. 6 less than 10. That's another way to write this. 6 less than 10. 6 less than 10. This phrase less than is going to be very important. This phrase less than right here is going to be very important. It's very important because a lot of people look at this and they say, okay, well, I know the word less might mean subtraction, or they might remember that less than indicates subtraction, but they get the order wrong because, and this is not even really a math issue. This is one of the conventions of the English language. So again, this is a reading issue. This ain't even a math issue, really. This is a reading issue. This is reading comprehension. And kind of like, I'm not sure if it's called syntax. I'm not sure. I would need to look that up. But 6 less than 10, that means you start out with 10 and you take 6 away. A lot of people get confused because they follow the order of the phrase, and they see 6 first, and they know that this deals with subtraction, and then you got a 10. So they think you're supposed to do 6 minus 10, but you're not supposed to do 6 minus 10. Remember, you got to really understand what this expression means. It means 6 less than this number. So if I wanted to express that, what I'm really expressing is 10 minus 6, because this is going to tell me how much I have if I have 6 less than 10. 6 less than 10 is like me doing, like, what number is 6 less than 10? Less than 10 means I start with 10 and I take 6 away. So then I'll have 6 less than 10, which leaves me with 4. 10 minus 6 is 4. So 10 minus 6, or you could say 10 decreased by 6. Now with decreased by, right? With decreased by, you do go left to right. You follow the order of the phrase. You do 10, and then you do a minus sign, then you do 6. Decreased by is straight subtraction. Decreased by is straight subtraction. But this phrase right here, less than, this is one of the tricky phrases in algebra, right? And in math in general, because it requires you to change the order of the numbers around when you create your mathematical expression. So 6 less than 10 is 10 minus 6. And I'm telling you, this is something you got to just drill into your head. You got to just memorize it, just practice it verbally or whatever. Write it down a whole bunch of times, because so many students get caught up in this. They see 6 less than 10 or something like that. It don't matter what the numbers are, no matter what the variables are. If it's variables in it, they want to do 6 minus 10. They want to follow the order. But you got to think. You got to switch the order around. You got to switch the order around. That's mandatory. All right. So what expression will represent this model? You know what? This is wrong. This was supposed to say minus. I was supposed to write the word minus, and then the answer to this was supposed to be 10 minus 6. All right. Now let's look at this last question. Could we also use 6 minus 10 as an expression to represent this? 6 minus 10. Could we use that? Basically, they're saying, is there a commutative property of subtraction? Because we've talked about the commutative property. Commutative property says that the order of the numbers don't matter. You're going to get the same answer anyway. So they're saying, is 10 minus 6 the same thing as 6 minus 10? If we could also use that, then that means our end result should be the same. Now, I happen to know, because I know how to do subtraction, 6 minus 10 is equal to negative 4. But 10 minus 6 is equal to positive 4. So these are not the same numbers. These are, in fact, they're exact opposites. So that means we cannot use 6 minus 10. All right, we cannot use 6 minus 10. Plus, let's set it up like, what if it was a bar diagram? The bar diagram always starts out with the first number. I think the term for that is the minuend, right? The technical term in a subtraction statement, the first term is called the minuend, and then the number that's being subtracted is called the subtrahend, right? So the first number is called a minuend, M-I-N-U-E-N-D. The second number, or the number that's being subtracted, is called a subtrahend. All right. So 6 minus 10. So what if we start out with 6, right? Let's do a bar diagram and see if it makes sense. So we got 1, we got 2, we got 3, we got 4, we got 5, we got 6. All right. So I got 6 boxes. Now I'm supposed to take away 10. Now, if I start shading in boxes, am I going to have 10 boxes to shade in? I'm not. I don't got enough boxes. So that's why it's going to take you to the negative side, right? You would end up with negative 4. But the mere fact that I can't shade in 10 boxes, whereas here, I started out with 10 boxes and I shaded in 6, and it left me with 4, I'm not going to end up with 4 boxes left over if I start shading in boxes. Because if I start shading in boxes, I'm going to shade in all 6 of these because I'm trying to take away 10 boxes, right? I'm going to shade in all 6 of these, and I'm still not going to have enough. I'm not going to be done. So that's why this is not the same. So it's kind of like it ain't enough. So it's kind of like, this made me think about, when I was going over this, I was thinking about the movie Friday when Smokey Mom tried to send him to the store to get us some cigarettes, and she gave him the money, and he was like, this ain't enough. And then she said to him, she was like, well, make it enough, right? So what does that mean? That means that the cigarettes might cost, like in this situation, if I wanted to apply that example, the cigarettes cost $10. She only gave him $6. So in order to make it enough, he got to get $4 of his own money so that he'll have $10 to buy the pack of Newports or whatever, right? So that's like That's like a real life application of this situation, you know. I don't know. That's just how my mind works. I be thinking about movies and I be thinking all types of stuff when I be doing math. But anyway, so yeah. So again, bar diagram, this is how we show subtraction. You start out with the first number, which is referred to technically as the minuend. That's the more sophisticated term. I'm 99% sure. Sometimes I get minuend and subtrahend confused, but I think the minuend is the first number. The subtrahend would be the second number. You start out with 10 boxes. You shade in 6. Once you remove those, what are you left with? That's how you show the difference. The difference is positive 4. What expression will represent this model? Yeah, 10 minus 6. I should have wrote the word minus. That's what I should have wrote. I messed up. But remember, this is real important right here. This is extra. This wasn't even in the book, right? Also know that 10 minus 6 is the same thing as 6 less than 10. Also, 10 minus 6 can be expressed as 10 decreased by 6. All right? 10 decreased by 6. All right? Also, you can say this. Let me give you another one. And these, you should memorize these. You're going to have to memorize these phrases. The difference between 10 and 6. Now, another reason why that's important to understand is because usually the word and implies addition. But in this case, because it's preceded by the word difference means subtraction. So in this case, and is a conjunction. That's a little, English grammar type thing. If you know what and means, and is just used in this case to combine the 10 and the 6. But we're trying to find the difference between them. We're not trying to find the sum of them. If we wanted the sum, then that would mean 10 plus 6. But when we want the difference, that means 10 minus 6, right? Because the word difference trumps the word and. If it was the word and just there by itself, then yeah, it would just be at straight addition, like 10 and 6. That means 10 plus 6. But if you got the word difference before that, the word difference trumps the word and, right? Difference is more important than the word and, basically. So that means that you're doing subtraction. You're doing 10 take away 6. All right? So that's example 4. Make sure you get the notes on this. If there's anything that you missed, make sure you run the video back, copy it down into your notes, play the video again if something didn't quite make sense and quite click yet. That's the beauty of the technology. Use it to your advantage. All right. So that's example 4. I'm going to see you on example 5. Peace.